The rational functions test review. Now we're up to adding and subtracting rational functions. Remember that to add or subtract a fraction, you have to have a like denominator. So, first thing you do is look, if there's a like denominator, you're good to go. In number 8, we have x squared minus 16, and x squared minus 16 is our denominators. So therefore, I can simply combine the numerators. So now I have the 6x minus x plus 20. At this point, I'm going to combine my like terms here and get 5x plus 20 over x squared minus 16. Notice I'm not factoring anything yet. Now, at this point, I'm going to factor the numerator, and I wind up with the 5x plus 4. That means I'm going to also factor the denominator. When I factor the denominator, which is a difference of squares, I notice that the x plus 4's will cancel. Okay? But before I start factoring and trying to cancel anything, if I factored over, well, actually there's nothing I could factor here, but if I had, I might have lost that common denominator. Now, I move on to number 9. Number 9, I have 3k plus 15, and over here I just have a 3. That means this is the same thing as 3 times k plus 5. I already have a 3, so I just need to multiply the numerator and the denominator by k plus 5, so that I will have a common denominator. Then I have to take this negative and I have to distribute it to both items in the numerator. So it's minus 4k minus 56. A common mistake would be to forget to subtract that 56 or to distribute the negative. Now, notice I leave the denominator factored. At this point, I'm going to combine my like terms, my 16k minus 4k and the 80 minus 56. That will give me 12k plus 24 over 3 times k plus 5. I'm going to factor the numerator. 12 comes out of both, so I wind up with 12 times k plus 2. Now the k plus 2 and the k plus 5 aren't going to simplify, but 3 will go into itself once and into 12 4 times. So my final answer is 4 times k plus 2 over k plus 5. Notice I do not distribute the 4. I don't go multiplying. I don't add, make more work for myself. I just leave everything in the factored form. Moving on to number 10. Again, this is addition, so I need a common denominator. So the first thing I do is, don't worry about the numerator, but in the denominator, I need factors of positive 9 that will add to negative 10. So it's going to be m minus 9 and then m minus 1. Well, I already have m minus 1 here, so I'm going to multiply the numerator and the denominator of just this second fraction by m minus 9. So I'll get 6m minus 54. All right. Now that I've got that, whoops, now I can show you. After I do that, again, this is the 6m minus the 54. I leave this one. I don't factor it yet because I want to combine my like terms. If I start factoring the numerator over here, it's going to be a problem. Now the denominator, notice I'm leaving that factored because once I combine my like terms, I might have things that will cancel. So I take and I factor, or I combine my like terms in the numerator, m squared minus m minus 72. So I'm going to look for factors of negative 72 that will add up to negative 1. And of course, that's going to be negative 9 and 8. So I do the m minus 9, the m plus 8. The m minus 9's cancel, and that leaves me with m plus 8 over m minus 1. Again, factoring is huge. This next one. This right here is a difference of squares. This is 2r plus 1 times 2r minus 1. Over here, I already have the 2r plus 1, so I need to multiply the numerator and denominator by 2r minus 1. I'm going to distribute the r, which will give me 2r squared minus r. So there's the 2r squared minus r plus 12r minus 6 because it's addition. I just keep that. And I leave the denominator factored. Now I'm going to combine my like terms, which in this case will be these two. And I have 2r squared plus 11r minus 6. There's no common factor. So now I have to find factors of negative 12 that will add to 11. And then I have to figure out how to handle the 2r. So this is going to be 12 and negative 1. This is fine. Over here, this reduces to 6 over r. So I'm going to have r plus 6, and then the 2r minus 1 will be my other factor. And boom, 2r minus 1, 2r plus 1 in the denominator, 2r minus 1, boom, and the r plus 6. The 2r minus 1's cancel, leaving me with r plus 6 over 2r plus 1. The 2 and the 6 cannot cancel. The r plus 6 is a whole thing, and the 2r plus 1 is a whole thing. All right? Continuing on, we have the next one is addition, and then we have another addition. This one shouldn't be too bad. You have 8a and you have 24. Well, I have to do this a times a and this one 3 times 3 so that I can get 24a as my denominator. Don't forget here that you have to multiply the 3 times the a and the 3 times the 4. Now you're going to combine the 3a and the 5a so that you will get 8a plus 12 all over 24a. Do not go and cancel that a yet. You can't do that. This is a plus stuff, so these a's don't cancel. I can, however, factor the numerator and taking a 4 out. When I do that, then 4 will go into itself once and into 24 6 times. I am now done. Yes, the 2 and yes, the 3, but they cannot cancel with the 6. It would have to go into both things. Next up, h plus 2, h plus 5. This is a case where you have to multiply this one by the h plus 2 over h plus 2 and this one by h plus 5 over h plus 5. Don't forget to distribute. 2 times h is 2h. 2 times 5 is 10. 5 times h is 5h. 5 times 2 is 10. Notice in the denominator I didn't multiply those two binomials. I just left them factored. Because now when I combine the 2h and the 5h, I'm going to get 7h plus 20 over h plus 5 times h plus 2. And notice I can't do anything else. Don't go multiplying this denominator. If you multiply it wrong, you're going to get points off. Just leave it in its factored form. Okay? Over here you had x minus 1, x minus 3, and the negative 4x plus 3. So I'm going to pause this for a second because I can't read quite over the writing to make sure that there's something else. Oh, I see what it is. Okay, this was x squared minus 4x plus 3. So this was x minus 1 times x minus 3. So this one right here is fine as is. So I just leave the x plus 1. This one, this first term, needs to be multiplied by x minus 3 over x minus 3. This needs x minus 1 over x minus 1. Again, the denominator, I don't multiply it out. In the numerator, this guy right here has to be FOILed, and this guy has to be FOILed. And notice that subtraction sign is right here because I'm going to have to distribute it to all three of those terms. Now, combining all my like terms, 3x squared minus x squared is 2x squared. Negative 10x plus 24x plus x is minus 7x. 3 minus 1 plus 1 leaves me with 3. At this point, I would look to see, are there factors of 5 that will add to negative 7? Because if there are, I want to factor it to see if I can reduce anything. Oh, sorry, 10. If there are, I want to reduce things. Sorry about that. I need to adjust my blinds in here because I've got bad light shining in my eyes. So 2 times 3. Let's see if I can actually do this for you. And duck my head out of the sun here. 2 times 3 is 6. Factors that add up to negative 7. And I have a 2x up front. This is going to wind up being negative, oops, hang on, I'm going to close the blinds. I can't see. Okay, sorry about that. So this is going to be negative 6 and negative 1. The negative 1 won't do anything. This is just going to be 2x minus 1. Okay, so that's where we get the 2x minus 1. This one, negative 6 over 2x, will reduce to negative 3 over x because 2 will go into 2 and into 6. So that becomes the x minus 3. Here I can cancel the x minus 3's, and it leaves me with 2x minus 1 over x minus 1. Do not cancel those x minus 1's. Okay? Now, that wraps up adding and subtracting. The next section is going to be complex fractions. All right, I'm going to pause here and just do the complex fractions as a separate entity.